Just in case some of the participants to this webinar is not yet familiar with the pen, so I just briefly introduce it. Okay, you may see me also from the webcam. Maybe better to see the presenter. First, I would like to go to the background that according to the Stockholm Convention Annex A Part 2, parties have to eliminate equipment and oils containing PCBs from use by 2025 and bring them to proper management, especially the resulting waste, under in environmentally sound manner by 2028. But many developing countries and countries with economies in transition has some difficulties with getting rid of the PCB oils and equipment in environmentally sound manner because of lack of capacities, poor inventories, limited resources, and also some inaccessible information. That's why this webinar also emphasize on inventories first as the first essential step to manage PCBs in environmentally sound manner. PEN is established as a collaborative framework to promote and facilitate information exchange with regard to environmentally sound management of PCBs. It is also intended to improve coordination and cooperation among stakeholders with regard to ASM of PCBs as well. PEN scope of activities quite varies, and its aim is to harmonize and coordinate activities already underway and supported by various donor countries, funding institutions, non-government organizations, and also international organizations which support developing countries and countries with economies in transition. One of the feature of PEN is its cooperation with clearinghouse mechanism of the Stockholm Convention, and also by raising awareness in successful ASM of activities, and also providing annual awards for contribution to the environmentally sound management of PCBs, which also done during the last conference of the parties of the Stockholm Convention. Now, there are some activities currently underway with PEN, but the most significant thing since the last part of last year until this moment is the development of guidance documents on the environmentally sound management of PCBs. And this guidance provide information and also some best management practices in inventories as one part of the development of guidance document, and the other guidance document dealing with the maintenance of PCBs equipment and facilities. And what we are having now is the webinar. The webinars this year will bring up the topic of inventories, which the first session conducted last Tuesday and the last one today, and also in June there will be also 2 sessions of webinars with which topic is the maintenance, and it will be conducted on 19th of June in English and 21st of June in Spanish. So we'll, for those who are interested in its topic, then you may also join the webinar next month in June. And the webinar topic in inventories is conducted due to the fact that most parties to the Stockholm Convention actually have developed preliminary PCBs inventories as part of the national implementation plan in their countries, but many parties only prepared partial or preliminary estimations of existing equipment and PCB contaminated oil due to mostly financial and time constraints. On the other hand, parties need a better picture of national situation of their PCBs management in order to take further steps in the environmentally sound management of PCBs and assess global progress in PCBs elimination and address PCBs in open applications. Our partner, our colleague here, Urs Wagner, will provide you with information based on his experience, in particular about open applications. And the objectives of this webinar on inventories are to provide guidance to parties, especially developing countries and countries with economies in transition, to enhance their current practices in PCBs inventories, and also to increase knowledge on PCBs in open application. We are happy to have Mr. Wagner to share his long experience as PCBs management expert internationally. But since this webinar is very limited, we may not be able to tap his experience, his long experience within a short time, less than 1 hour. He said that the training packages for inventories of PCBs usually take at least 1 day, but it has to be squeezed in less than 1 hour actually, because part of the time is taken by me and the discussions. Okay, I think I have to sign off. Sign off from the presentation. And I thank you for your attention. But should you need more information, please our website as displayed here, or contact me at also the indicated email address. Thank you very much, Chihye. I'm returning the ball to you.
Thank you very much for your presentation, Dadan. So I'll take the ball back to me. And now we can go on to our main presentation, which will be done by Mr. Wagner. I'll pass the ball to you.
Thank you, Chihye. Thank you.
Now you have the ball. Yes, please go on.
I trust that you hear me. Good morning, and to part of you, good afternoon out there in the world of POPs. Very special greetings to Moi, South Africa, and Shani, respectively, Blanchi to Zambia. I'm still confused. This is the second time I do a webinar, and I'm confused just to talk to my desktop, not having faces in front of me. But again, I will try to do my best, and I trust that you're going to interrupt me if it is hard to follow or if you cannot understand me anymore. As Dadan actually mentioned before, I tried to start my presentation. Yeah, it's working. As Darren said before, it is quite a complex topic, as you are all aware, PCB, and to squeeze all these general information into 25 minutes, it's almost impossible. So therefore, please accept my apologies that I just briefly touch a couple of what I feel are important topics, and whoever is interested in knowing more, there are a lot of guidance materials, of publications, of fact sheets available, and at the end of my presentation, I will give you some links to these documentations. Let me just first show you where I'm talking to you. You see here red Switzerland, and if you can follow this icon here, you see the left part. Now I covered almost whole Switzerland. On the left part, there is Geneva, where Darren talked to you, and I am actually at the other side of Switzerland, bordering to Austria and Italy, and a very tiny little principality, the Principality of Liechtenstein. And this is my city where I'm living, Chur. That's really how it looks like. It's slowly becoming summertime here, and there where the red arrow is, this is pointing to my office, and this is how I look like. Sorry, I do not have a webcam on my desktop. Next time I might talk from my notebook. What are the table or what are the topics we're talking about? Just briefly, some general information about polyfluorinated biphenyls, the status of inventories with a general view about the regions, some recommendations how inventory process of specifically closed application could look like. Then we are going into the topic of open applications, PCB applications, and as I mentioned before, I would like to introduce some documentation to you. Well, when we talk about PCBs, we should consider that they are everywhere in the environment already, and basically on a daily basis, we all have an intake of PCB, for instance, by food. And very typically for PCB is that their main technical advantage and also economical advantage is at the same time seen from the point of view of the environment and the health is a disadvantage, simply because these products are persistent. They are stable to aging. And if we consider, for instance, this is an open application, corrosive protection paint, which is lasting for probably 40 years. If I take my country with hot summers and very cold winter times, and consider that I do not have a lot of maintenance work to be done, so this is a big technical, respectively, economical advantage. But at the other side, if it is once in the environment, it's going to bioaccumulate and it's going to resist there. And as we know, it is harmful to wildlife and human beings. I apologize at this stage that I'm talking very fast to you in order to rush through all the slides. Hopefully afterwards during the discussion session, I can slow down the speed of my voice as well. Well, we all have the aim 2028 to complete the environmental sound management, respectively, the phase out by 2025 of PCB containing equipment. Now, it is up to you to judge where in this pyramid you stand today. But many countries, they're still in the stage of preliminary inventory or PCB assessment phase, which, as Dadan said before, I personally believe it is the most important one, because all the future management decisions, disposal decisions, they are basing on the outputs of the inventory. Now, usually in the countries, as I said, we focus on preliminary inventories. These preliminary inventories, however, are only a snapshot of the problems, and only fractions of the total number of electrical devices have been sampled and screened so far. So therefore, a preliminary inventory is nothing else than just an estimation, a calculation. So this was okay during the NIP phase, but now we need facts, and therefore we really have to physically inspect, sample, screen, and if necessary, analyze all electrical devices which might be containing PCB or are contaminated by PCB cooling fluid. Well, in all regions, as I mentioned before, only fractions of equipment have been screened and analyzed so far. And talking about inventories, we have to consider not only the equipment which is in service, but also the equipment phased out. And most important, we have to focus on spare oil, on contaminated sites, and specifically we have to involve maintenance and repair workshops into our inventory process. We have to raise their awareness because according to my opinion, in almost all countries, this is the main source where we still have a cross-contamination of clean equipment by contaminated oil simply because many of these maintenance workers are not aware of the PCB problematic. My colleague Ana Ortiz from Costa Rica, who is also in the advisory board of the PCB elimination network, she is going to make some presentations about maintenance specifically in June this year. You may find the information about these webinars also on the Stockholm Convention website. Now, the first step when we are compiling an inventory is that we may involve all potential stakeholders. You know these proceedings, of course, but still it is tricky because usually we focus on utilities, electricity utilities, and it is okay because they usually have the majority of electrical devices of huge transformers in hand. But we also have to take care about what we call the small consumers, because basically in each building, in each industry, we will find transformers and capacitors, and we have therefore to identify further potential users, which probably during the NIT phase we did not get hold of. Then the inventory process, as I said, we have to focus on equipment in service, but also out of service, and machinery, spare oil. And we should somehow consider such a compiling of an inventory at the same time as a risk assessment opportunity, that we consider also what is the condition of an electrical device, what is the remaining service life, simply because if we have a transformer, for instance, contaminated by PCB, it's 60 years old, it's very unlikely that the owner intends to make use of it further than 2025. It might be too risky and more economical, regardless of the PCB problem, to replace it by a new transformer. At the same time, very often utilities, they check the oil quality of transformers as a kind of preventive maintenance. So the time they take these oil samples, we could get involved by compiling our PCB inventory and can reduce the costs and the time of compiling an inventory by using this opportunity. I show you how an approach of a PCB inventory could look like. Of course, this is country or even industry specific, and it is just a recommendation. We will start with a preliminary inventory. This can be that we're going to send out questionnaires to the potential stakeholders. Then we're going to compile a physical site inspection, but I do not like the word inspection because in many countries we do not have yet the regulation in place. Therefore, I would not like to show up like the police, we come as friends. We want to assist the owner of the electrical components in finding solutions, and therefore we rather call this site visits. We take samples from the equipment. If there is any emergency, there is leakage or whatsoever, we can give advice and recommendation on emergency actions. Then we do the screening by using test kits, for instance, and whenever necessary, we go to verification in a laboratory using test kits means that we usually can reduce the volume of samples which need to be analyzed in a laboratory down to 10 to 20% of the total number of samples. Most important, we have to feed a database, and the time is over for these Excel-based databases. We need real database, not Excel sheets. I also come back to that issue later, because all the information we gathered will be the basis for us to discuss about PCB management options. And they may vary from region to region, from country to country, from company to company. At the same time, the database is also our tool for priority setting. For instance, if I have a PCB contaminated transformer in bad condition, leaking already nearby a food processing plant, so this, of course, will be a higher priority to replace rather than a transformer in good condition in an electricity utility in an industrial area. As I mentioned before, we have to introduce the topic to maintenance and repair workshops, and then we come to the phase out. We obviously need resources for transportation. We should establish a tracking system in order that we're not going to lose equipment. And usually such a tracking system, we should not only focus on PCB, but we can work it out in general as a hazardous waste tracking system. We need in the countries interim storage facilities. Also, these interim storages must not necessarily be focusing only on PCB. It can be a general hazardous goods interim storage. We always have to update the database, that we have the latest information where the equipment is, and then we may go for the treatment or for disposal. There are many options available. But again, we should only start to talk about treatment and disposal the time we know about specific PCB problem in our country. For instance, if we have more contaminated oil for treatment, then a non-combustion solution might be more favorable. When we have specifically PCB containing capacitors, then most likely incineration might be the best solution, pack and ship. Here you see diagram how such a screening during an inventory can look like. I do not have the time to go into details, but you will get this presentation and you can study this diagram later on. So what are we looking for when we compile an inventory for closed applications? Of course, transformers in service, high voltage, medium voltage, and low voltage capacitors, spare oil, phased out electrical devices, any kind of machinery like vacuum plants or oil recovery machinery. We take care about any kind of emergency leakages, etc. This is important because the treatment, of course, is different of PCB contaminated concrete, for instance, and it should also be part of the inventory. Obsolete stocks we have to consider, and also small size capacitors as we find them in each computer, washing or laundry machinery, etc. But again, it should be equipment, or it must be equipment, which is manufactured before 1990. We are going to use questionnaires. Also here, we should not reinvent the wheel. There are good specific questionnaires established from the Stockholm, respectively Basel Convention already. You may adapt them to the needs of your country or your company. And as I said before, we always should catch a glimpse behind the scenes. We should really go personally to the sites and judge the situation, not rely just on information received by letter or phone. Talking about small size capacitors and transformers, street lamps is something that has been dramatically underestimated, very often not even considered. And of course, such a small capacitor does not contain a lot of PCB, I agree, but in a country we have a couple of street lamps normally, and therefore in total it's still something that we have to consider. Then very important topic are the ballasts. Ballasts do contain transformers, switchers, and for instance in the United States they have been produced with PCB until 1979. In Europe they have been produced until 1987, and these ballasts, they are lasting for centuries almost. Therefore, still in my country, for instance, more than 50% of the ballasts in the buildings erected before the 90s contain PCB ballasts. Or electrical locomotives, they also contain these kind of devices. What we also should consider in certain industries, like in the mining industry, these devices, these PCB containing devices have been used on purpose because they have been very safe regarding potential fires, and therefore they're full of these applications in the mining industry. What we also should consider, these ballasts in fluorescent lights very often are connected with another hazardous substance, with asbestos, because it was likely that a short circuit could happen, and in order to prevent a fire, these asbestos cardboards were often fitted under the fluorescent lights. And there is a much more direct health impact from the asbestos than from the ballast, because if they are intact, there is no PCB evaporation. The database. This is, as I said, most important, and very often countries, they have problems in establishing such a database. Here I would like to link you to the Basel Convention Secretariat. They established a toolkit for these PCB inventories, and I'm pretty sure that Darren or Matthias can give you further information about this toolkit. There are some side effects when we compile an inventory. We can do awareness raising, of course, with the staff out there in the companies we visit. We can do capacity building. These both are topics actually which will accompany us until 2028. It will never end actually that we do awareness raising. And also I'm 30 years now in this PCB consultancy. I'm still learning. I'm still learning on an almost weekly basis. So it's hopefully not a never-ending story, but at least it's a story which is going to be with us until 2028. A good side effect is also that we can learn from the environmental management of PCB devices and waste, how to manage in general other hazardous waste, and of course we may adapt regulation. The most important step for whatever activity we have with PCB is a reliable inventory in order that this is not going to happen, because if the inventory is not correct, then it's like the domino game. Everything will fall down if we apply the international community, for instance, for CHEF funds, and our figures are not correct, well, we will end up in a mess. Therefore, we should invest the necessary time and also funds in order to compile reliable inventory. You will find more information about PCB inventory of closed applications in this first edition of the PEN magazine. I just got here the Russian one, but it is available in all UN languages, and you may download from the website of the Stockholm Secretariat. Yeah, the iceberg. You remember I said in the very beginning that we usually focus on electrical equipment, electricity utilities, but the real challenge is actually what is not so obvious, what is below, beneath the surface, and this we also should consider in our inventories. This brings me to the next topic, to the open applications. Some of you are probably well aware of it. Some others might be shocked that the story is going on and we may not only focus on electrical devices. It is clearly stated in the Stockholm Convention that we also have to take care about other articles containing more than 50 milligram per kilogram PCB. And for instance, is specifically stated cable sheeting, which might be either impregnated inside, or the cable sheeting itself might be treated with PCB as a kind of flame retardant. Then cured cork, as the Americans say, we in Europe rather use the terminology sealant. Here, PCB has been used as a weakener, and indeed, these sealants, they lasted for 30, 40, 50 years, whereas sealants that we're using nowadays is lasting for probably 5 or 10 years, and then we need to replace. You see also here, PCB has some advantages, at least from the technical point of view. And then most important, because this is a widely used application, paint, respectively, specifically anti-corrosive painter. If we remain with the electricity industry, just looking at this example of a hydropower plant, then we see enormous possibilities where we could find PCBs. Is it in anti-corrosion coatings? Is it in caulks or sealants? It's amazing, and usually this has not been considered when compiling an inventory on such a site. Here we see some pictures from pipelines, water pipelines of hydropower plants, and these coatings you find inside the pipeline and also outside, and therefore you can imagine that also the land around such a pipeline is meanwhile contaminated by PCB, and of course heavy metals and even asbestos has been used in these kind of coatings. We are still in the electricity industry. You see here turbines, pumps, motors, etc. There are many, many applications you may find in these industries. And at the end of the day, as these pictures from Benin show, because people are not aware of it, it's going to be improper recycled, and specifically when we're going to use fire or heat, we're going to produce byproducts such as dioxins and furans, and therefore, again, we need to continue with awareness raising and capacity building. Widely used application, of course, are the sealants. This building you see here is full of this PCB containing sealants in the walls, but also the connection between the windows and the concrete, for instance. And therefore, the focus in the United States and Europe is to prevent further environmental pollution by improper replacement of these sealants. We have to consider that specifically if we have these sealants inside a building, that we have a pollution of indoor air, and this pollution can be very high in some cases. And we have a depletion into the concrete structure. This is a consequence that we can't just replace the sealant and then the problem is solved. No, because the new sealant is going to be soaked by the PCB, which is going to diffuse from the structural condition. Cable sheeting, I mentioned before, you find in all industries, but as I said, specifically also the mining industry. These anti-corrosion coatings we can also find on ordinary heating oil tanks, on radiators, for instance, which we have in all residential buildings as well. Basically in all paint applications from former years, of course, we can find it. Common use in Europe has been also as flame retardant in ceiling tiles. And if we are in bad luck and do not have PCB as a flame retardant, then we will find asbestos fibers in these ceiling tiles. Floors, specifically industrial floors, PCB has been widely used as a weakener, but we also find it in rural areas, in residential buildings, as these pictures show. So PCB is in all parts actually of our lives. I'm coming to the end of my presentation. I would like to show you just quickly a couple of slides how we remove in Europe, for instance, these applications. Now this is what I call the Greenpeace option, the really complete removal of not only the sealant but also the contaminated structural part. This is possible when a building is renovated and is going to reconstruct according to what we call Minergie standards. That means that the whole building is covered with isolation so that you don't see these remaining holes where the sealants have been. I'll try to switch now on my desktop, then I can show you that very often you find PCB also in floor coatings or even in adhesives. On this movie, you see in a school building how the adhesives are going to be eliminated. Excuse me. You see the workers here, they are working under vacuum condition with full personal protective equipment, and this machinery is linked to industrial vacuum machine with activated carbon, industrial activated carbon filters to catch all the PCB. And on the left side, we see the removal of painted concrete floor, again with specifically developed machinery. Here this was during a testing phase, and in Switzerland we find these kind of floors, for instance, in almost all industries and very widely also in residential buildings. So I try to go back to the presentation. Does it work? Yeah, it's working. So the goals and objectives of taking care about open applications, of course, is that we can go for an environmental sound and complete removal of what we call primary sources. Probably I have to mention here, we call primary sources all kind of material where PCB has been used on purpose to change the properties of that material. For instance, a sealant should remain elastic, withstanding hot summers, cold winters, to last for a long time. Whereas secondary sources are materials which have been contaminated by evaporation of PCB into these materials. In Europe, we usually focus on the maximum indoor air contamination of 300 nanograms per cubic meter. For instance, in my city here in Chur, as you have seen before, we had a school building where we found 11,000 nanograms per cubic meter air. This building has been decontaminated meanwhile. And if we talk about anti-corrosive protection paint, for instance, you see here technology with high water pressure in order to remove the PCB containing paint, and eventually very fast it looks clean, but we take then wipe samples, as you may see on the right corner, in order to prove the success of the decontamination. There are other technologies like the needle pistols in order to remove these PCB coatings, and at the end, of course, all the sludge, respectively, the paint and associated waste like personal protective equipment has to be incinerated. Now I'm coming to the end, and I would like to introduce you some photo booklets and brochures that PEN is at the time developing. It's still in the draft stage, but the intention is that we may provide you with information. Where do we find PCB open and closed applications, how they look like, what are the immediate potential or high risks, and how can we handle these problems. The same is fact sheets about open systems, respectively open applications, and you will be all informed as soon as they are available on the website to download. So I'm coming to the end of this very, very brief and fast introduction of some topics of the very complex PCB issue. I thank you very much. I'm at your disposal right now for any questions. and just take care whether you're pilots or whether you're compiling an inventory. Thank you very much. I hand over the ball back